NASA has a plan to build a base on the moon before sending humans to Mars so that the journey to Mars becomes shorter. SpaceX founder Elon Musk wants to win the race to reach Mars. Besides him, European and Russian space agencies also talk about sending humans to Mars. But how will humans survive after landing on Mars's harsh atmosphere? Because unlike Earth, Mars doesn't even have the oxygen humans need to stay alive. What solution has NASA come up with for human survival on Mars? And why won't the same method used to produce oxygen on the International Space Station work effectively on Mars? Welcome once again to Cosmic Visions videos, viewers. There are many reasons behind humanity's desire to live on Mars, including scientific exploration and space curiosity. But among these wishes, there also lies a necessity, or perhaps a fear. That fear is that, due to some disaster on Earth, the human race might become extinct, just like the dinosaurs were wiped out from our planet 65 million years ago. And this is indeed possible, as we're already witnessing in the form of climate change. This might be the biggest reason why, in the near future, someone may become the Neil Armstrong of Mars. At one point, Elon Musk aimed to colonize Mars by 2026, but now he has predicted the year 2029 instead. On the other hand, NASA has also planned to land humans on Mars by 2030. But the real question isn't who will get to Mars first. The real question is, how will humans survive after reaching Mars? While it's true that Mars shares many similarities with Earth, for example, a day on Mars, called a Martian day or sol, is only 39 minutes longer than an Earth day. Mars also experiences different seasons, just like Earth. Earth has ice caps at its poles, and so does Mars. Earth has an atmosphere, and although thin, Mars also has one. But the one thing that is completely inadequate for human survival on Mars is oxygen. So, how will oxygen be produced on Mars? And not just for one or two people, but enough to sustain an entire colony? In extreme situations, when we think about keeping humans alive in space, the first thing that comes to mind is the International Space Station, ISS. It has survived the harsh conditions of space for over 25 years and continues to provide astronauts with oxygen and fresh water. At any given time, 4 to 5 astronauts live on the ISS. Their daily water requirement is at least 45 liters, which means 1,350 liters per month and around 16,200 liters per year. In addition to that, about 1,000 kilograms of oxygen is used annually. So how is so much water and oxygen produced 400 kilometers away from Earth? To achieve this, the ISS uses two main systems: Water Reclamation System, WRS, Oxygen Generation System, OGS. But why can't we use these same systems on Mars? To understand that, we first need to understand how these systems work. The Water Reclamation System, WRS, collects water from human waste, including urine, sweat, and humidity, and purifies it to make it drinkable again. Astronaut Douglas Wheelock once said, "Today's coffee is made from yesterday's coffee." This WRS purifies already existing water, making it reusable and saving up to 98% of it from being wasted. Alongside it is the Oxygen Generation System, OGS. This system takes a small amount of water from the WRS and passes it through a special process known as electrolysis, something we all studied in school. In electrolysis, an electric current is passed through water, which splits it into oxygen gas and hydrogen gas. The oxygen is used for breathing, But hydrogen, a highly dangerous and flammable gas, can turn into a fireball in seconds. So instead of wasting the hydrogen, it is sent into another machine called the Sabatier system. This system collects carbon dioxide exhaled by astronauts and combines it with the hydrogen gas. The reaction creates water, methane gas, and a small amount of heat. The water is recycled back into the WRS. The heat is transferred to the station's thermal management system, but the methane gas, which is extremely valuable on Earth and can be used as fuel or energy, is simply released into space. Why? Because using methane as fuel requires more oxygen, and oxygen is already the most precious resource here. If we analyze this entire oxygen and water production system, we'll see it depends on refueling missions from Earth. Even though these systems are 98% efficient, every system has some losses and leakages. That's why every 6 months to a year, water and oxygen are resupplied from Earth. But these refueling missions are extremely expensive. Sending just 1 liter of water from Earth to the ISS, which is 400 kilometers away, costs around $2,500. So, using the same system to produce oxygen on Mars, which is 225 million kilometers away, would not be cost-effective at all. That's why we'll need a system that can use Martian resources to produce oxygen directly on Mars. In 2021, the Perseverance rover that NASA sent to Mars was equipped with a device for this experiment called MOXIE, which stands for Mars Oxygen In Situ Resource Utilization Experiment. Because in this system, the source of water is refueled. But on Mars, to find water, one would have to go to its polar caps or drill several feet deep to extract ice. That's why MOXIE produces oxygen from Mars's own atmosphere by using carbon dioxide. How? To explain in simple words, Mars's atmosphere contains 95% carbon dioxide. MOXIE first pumps the carbon dioxide from the atmosphere and pressurizes it, then puts it into an electrolyzer and heats it to 800 degrees Celsius, which separates the oxygen gas from the carbon dioxide. This electrolyzer is made of gold because gold is an excellent heat conductor, and it protects the other parts of Perseverance from the heat. Through this process, along with oxygen, carbon monoxide is also produced from the carbon dioxide. The problem is, if the carbon separates completely during this process, it can also form a layer of carbon, just like the black layer we see under a cooking pan. And this layer could quickly damage the Perseverance rover. That's why this process is performed very carefully. But how much oxygen does MOXIE produce at a time on Mars? This process requires a lot of energy, so NASA only runs it occasionally, when extra energy is available from the solar panels. Until now, it has produced only 122 grams of oxygen, which can keep one person alive for just 3.5 hours. If in the future we want to produce more oxygen on Mars using this system, then a larger version of MOXIE would be needed, along with a large power plant to run it. And this is currently the biggest challenge. Now, the important thing to understand here is that MOXIE compresses carbon dioxide with the help of a compressor and then heats it to 800 degrees Celsius. Both of these processes require a lot of energy. To solve this problem, scientists are working on a future technology in which the carbon dioxide molecule can be broken down at lower temperatures. In this method, instead of heating carbon dioxide, vibrations are generated inside it to separate the oxygen molecule. Currently, This technology has been tested in a lab, but due to Earth's high atmospheric pressure and temperature, it's not possible to implement it on Earth. However, Mars's atmosphere is perfect for this process. Whatever the technology may be, our goal is to use a method on Mars that can produce oxygen on-site using local resources. And the devices used to produce this oxygen should also not be dependent on Earth. Why? Because the ISS is only 400 kilometers away from Earth. If its oxygen-generating system fails, astronauts can simply wear their oxygen suits and wait a few hours until a new supply arrives from Earth. But on Mars, this won't be possible. Humans won't be able to return so quickly. Is it even possible? Share your valuable thoughts in the comments below. It may seem impossible for now, but let's see what the future holds. We hope you liked this video. Don't forget to like, share, and subscribe so that with your love and motivation, we can continue bringing more unique topics. Thank you.